Please now join me in welcoming Jae Kwon, who is a co-founder and lead developer of the Cosmos Network. In 2014, Jae introduced Tendermint, a BFT consensus algorithm and peer-to-peer networking protocol in one. Today, Tendermint is used as a consensus engine which powers Cosmos. Jae.
All right. Okay, so before I get started, I just want to talk a little bit about the background, Tendermint. So I've been a developer here for a while in Silicon Valley for about over a decade now, and I love open source software, and I love modular good design. And in 2014, after I decided I wanted to get into the blockchain space and commit myself to the Bitcoin revolution, I realized that proof of work might be an issue in the future, and so now here we are 4 years later, and we have a big debate about proof of work versus proof of stake. So with blockchains, you need distributed Byzantine Fault-tolerant security, and proof of work is a great way to do it. Oops, gonna go back. Yeah, but it doesn't scale. Like proof of work, you can only have one chain. If you have many chains, many blockchains, you can't really have proof of work. It doesn't work well because you can have miners that switch over. And so, the question now is, what do we do? What kind of proof of stake system should we go to? And so there's Casper. You've heard of Casper. Have you guys heard of Casper or Ethereum? Yeah, yeah. And there's also Algorand, and there's a few, other BFT algorithms out there. But in 2014, we published a paper, Tendermint, Consensus Without Mining, that brought existing BFT algorithms and showed how it could be used in a proof of stake context. So at this point, it's pretty clear to us that that was the right decision, that classical BFT algorithms that have been developed since the 70s is the right way to go about creating a proof of stake system. Sorry, my timer's not going down, just FYI. Okay, so we've built Tendermint. Tendermint is an open source Apache 2.0 consensus engine that you can use to create any blockchain, permissioned or public. But it's not enough to have a kick-ass, state-of-the-art advanced consensus algorithm. You still need to provide tooling to make it easy to develop blockchains, and that's why we have things like Ethereum, like Solidity, and why virtual machines are so exciting, because these are all platforms to help enable developers to create their blockchain application. And we have a particular opinion about how to do that. So starting with Go, the language, which is what Tendermint is based on. Go is a language developed by Google. It's pretty fantastic, being a very minimal language. And we've developed a framework to develop new blockchain applications, kind of like how Ruby on Rails or Django revolutionized the Web 2.0 industry. We believe that what's needed for the blockchain industry is a good framework to develop your blockchain in. So I'm just going to show some slides that go through the code. So this is mostly a slideshow for developers. So let's see how the SDK works. So the Cosmos SDK is an open source framework that integrates with Tendermint. So if you just build on the SDK, and I'll show you some slides here, and build it, then you get Tendermint baked in, and you can create a blockchain really easily by using our SDK. So the first part I want to show you is the KV store. So what you want in a blockchain is you want the ability to have key value pairs persisted, but you also want to be able to produce a Merkle proof. And this is the basis of like-client verification, and it's also the basis of inter-blockchain communication, which is what Cosmos is about, but I won't go into that. So Ethereum has a Patricia tree. Bitcoin doesn't have anything besides the Merkleization of the transactions per block. But the Patricia tree, it's nice, but it's also not the most efficient structure for proofs, for Merkle proofs. So we've developed our own, and it's provided to you by a very simple interface. It has a simple get-set mechanism, right? And what you notice here is that the keys and values are arbitrary bytes. So it's a very nice system to use. You don't have to split your data into 32-byte chunks. There's also an iterator so you can iterate over your persistent store, right? So all the account balances, and you can create an application that might need to iterate over multiple rows to do some kind of compaction, and you can do so easily using our SDK. There's a lot more here that I could get into, but something about software transactional memory, maybe I'll get into that in a bit. So you can create multiple of these KV stores and attach them to your application. It's kind of like a file system. And so you can attach many kinds of Patricia or Merkleized trees and then have the SDK manage that for you like a file system you just mounted, and then you can provide proofs into any part of your storage system. And of course, there's a query mechanism so that you can create services or applications that consume the RPC endpoints to get proofs, Merkle proofs into the state of your application. So that's just one part of it. Persistence is really nice in our SDK. Here's something about codecs, so encoding and decoding in binary form. Have you guys heard about protobuf? Any developers here know about protobuf? Yeah, it's a message scheme, and it's a standard for persisting messages so that you can communicate them across processes. Well, protobuf is great, but it's not really ergonomic to use. So what we've done is we've developed a reflection-based library so you can just create Go objects, and this library can persist anything, serialize anything to bytes. And so we use it extensively in Tendermint and in the SDK to make development much more streamlined, because you don't have to worry about schema files. It just uses reflection and it just serializes it. The other nice thing about it is that it supports interfaces. So like protobuf doesn't support interfaces, and that means you can't quite use those messages from the protobuf schema as your logic application objects because it doesn't quite match. But so for example, here there's crypto.pubkey, it's an interface. You can't really deal with that in protobuf, but using our library you can. And so you can, there are multiple concrete types of pubkey, like an ed25509 or SecP256K, and serialization is really easy. So all you have to do is register the concrete types given the interface. So this is kind of how you register all the different types for an interface that you might want to serialize. So check that out. It really makes development much more streamlined. So if you were to go to our SDK directory, I'll have a link to it later, you can see how we use it everywhere and how we don't have any protobuf schema files. Keys, keepers, and mappers. So I'm going to go over briefly about a design paradigm that helps encourage secure development, secure libraries. So everything, all the stores in the SDK are keyed by a key, an object, in this case, SDK.storeKey. And the idea is that without this key, you can't access the store. So why do we do things this way? It's because we want to create an ecosystem of libraries so that you don't just use our SDK, but you can import modules, right? We're creating a new ecosystem of libraries for blockchain development, and we want to make it so that the ecosystem starts from a foundation of least authority. So this way, you can make sure that all the libraries that you use only have access to the things that you need. And so we're instilling from the basis good design principles around object capabilities. And it's used everywhere. So a count mapper, for example, is an object that gives you access to the store. And when you initialize it, you have to give it the key, which gives it access to the store. Right? So if you look at the implementation of the account mapper, you'll see that it gets the KV store from the context using the key. And this is a design paradigm that's used all over in the SDK and makes it much safer. Here's a transaction format. You can use any transaction format that you like in the SDK. So you could create, for example, an SDK application that is functionally identical to Ethereum, because Ethereum transaction formats can also be supported. But ideally, you just want to use the standard transaction format here. And the way you use Amino is you would register all the transaction types, the message types. And so the SDK knows how to decode a transaction. And then you have a routing system so the right handler can get called to process your transaction. Here's another nice feature of the SDK. There's a thing called end blocker, so you can have logic that runs at the end of every block. So you can use this for things like background processes or garbage collection, whatever you need in your application. You should really check out the staking module. So with proof of stake, it's not sufficient to have BFT consensus. You really need a good staking system, and we've developed an amazing system based on delegation with real skin in the game, and the logic is all there, so check it out if you want to see how to, an example of a complex application written on the SDK. If you want to build a new blockchain and you're interested in figuring out what the best framework is, there's no question this is the one you want to build on. Depends on your application, but check it out, and check out Cosmos Network and Tendermint. Thank you.